Welcome to the ASM Educational Center video. Today, we will talk about Section 3.4 from the CompTIA Network Plus exam.
All right, so here's what we're going to cover. First, we'll look at the network's foundation. Then, we'll dive into how your devices get online with dynamic addressing. After that, we'll tackle name resolution, how we find everything on the internet. We'll also touch on time sync, which is more important than you might think. And finally, we'll wrap it all up with a rapid-fire review of the exam essentials. Sound good? Let's jump in. So let's talk about the network's foundation. It's really easy to get caught up in disaster recovery plans, right? Thinking about what happens when everything just breaks. But what about the stuff that stops things from breaking in the first place? That's what we're digging into today. We're talking about the unsung heroes, those core foundational services that keep our networks running smoothly every single day. Okay, on to our next topic, dynamic addressing, getting online. So think about this. The absolute first thing any device needs to join a network is an IP address. But how does that even happen? You don't manually punch in a bunch of numbers every time you connect to Wi-Fi, do you? So what's the magic behind it? Seriously, just picture it. You walk into a coffee shop, you pop open your laptop, connect to their Wi-Fi, and bam, you're online. You didn't have to configure a single thing, right? No IP address, no subnet mask, no gateway. It just worked. Well, that seamless, almost magical process is exactly what we're about to break down. And trust me, it's all thanks to a protocol that you have to know for the exam. And that magic is called DHCP, the Dynamic Host Configuration Protocol. You can think of DHCP as the ultimate network workhorse. It's basically a system with a central server that's in charge of a whole pool of IP addresses. As soon as your device joins the network, this server hands it an IP, plus all the other critical info it needs to start talking to other devices. Simple as that.
Okay, to really get DHCP, you've got to know the lingo. It's super important for the exam. First up, the scope. That's just the pool of available IP addresses the server can hand out. Think of it as its inventory. Then there's the lease time. This is how long your device gets to borrow its IP address before it has to check back in. Now, a reservation, this is cool. It's like a permanent VIP parking spot for a specific device, like a network printer. It's tied to the device's unique MAC address, so it always gets the same IP. We also have exclusions. These are IPs within the scope that the server is told never to assign. You save these for important things like your router. What about big networks? That's where a relay or IP helper comes in. It acts like a messenger, forwarding DHCP requests across different subnets. And finally, you have options. This is the extra good stuff DHCP provides, like the address for your DNS servers and your default gateway. It's the whole package. So while DHCP is the king of the castle, especially in IPv4 networks, IPv6 has another trick up its sleeve called SLAAC. And you absolutely need to know the difference. Here's the main takeaway. DHCP is what we call stateful. That means there's a server keeping track of everything. It's managing a list, a state, of who has which IP. SLAAC, on the other hand, is stateless. There's no central server keeping track. A device just listens for announcements from a router and figures out its own address. Totally different approaches.
All right, so our device is on the network, it's got an IP address, we're in business. But now we run into a very human problem. We don't like remembering long strings of numbers, do we? We like names, and that's exactly what our next section is about. Name resolution, or how we find everything using names we can actually remember. So let's ask a simple question. When you type asmed.com into your browser and hit enter, what happens? How does your computer find the right server out of the billions on the internet? Because here's the thing, your computer has no idea what asmed.com means. It speaks in numbers, IP addresses. So there has to be some kind of translator working behind the scenes. What is it? And that translator, my friends, is the Domain Name System, or DNS. The best way to think about it, and this is a classic analogy for a reason, is as the phone book of the internet. It's that simple. You look up a name you can remember, and DNS gives you back the number your computer needs to actually make the call. Honestly, without DNS, the internet would be basically impossible for us to use. Okay, so this phone book isn't just one giant list of names and numbers. It's actually really organized, using different types of records for different jobs. And yeah, you're definitely going to need to know these for the exam. Let's run through the big ones. First, the A record. This is the most basic one. It just maps a domain name to an IPv4 address. Its sibling is the AAA record, that's Squad A, which does the exact same thing but for the newer IPv6 addresses. An MX record stands for Mail Exchanger. It tells the internet where to send email for a domain. A CNAME, or canonical name, is an alias. It just points one name to another name.
Then you have the PTR record or pointer record. It does the reverse lookup. You give it an IP and it gives you the host name. And finally, the TXT record. This one just holds plain text and is super important these days for email security, for things like SPF and DKIM. Here's a crucial concept. Not all DNS answers are the same. You have to know the difference between an authoritative answer and a non-authoritative one. Think of an authoritative server as the official record keeper. It holds the original master copy for a domain. It is the ultimate source of truth. A non-authoritative server, on the other hand, is just providing an answer from its memory, its cache. It looked up the info from an authoritative server earlier and is just repeating it. The answer is probably right, but it's not coming from the original source. And even within a company's own authoritative servers, there's a pecking order. You've got the primary DNS server. This is the boss. It holds the master copy of the zone file, the one that can be edited. This is where administrators make all the changes. Then you have the secondary DNS server. Its job is to hold a read-only backup copy. Why? For redundancy. It's a lifesaver. If the primary server goes down for any reason, the secondary server can just step right in and keep the network running. Now, because DNS is so fundamental to how the internet works, it's a massive target for bad actors. So we've developed ways to protect it. First, there's DNSSEC. This adds digital signatures to DNS records to prove they're legit and haven't been tampered with. It's all about authenticity and integrity. Then, for privacy, we have two big ones, DOH and DOT. DOH is DNS over HTTPS. It encrypts your DNS queries and cleverly wraps them inside normal web traffic on port 443, so they're hard to spot. DOT is DNS over TLS. It also encrypts your queries, but it uses its own special dedicated secure channel on port 853. Both are designed to stop anyone from snooping on what websites you're looking up. Okay, let's recap. Our device has an IP address. Check. It can find other devices using DNS. Check. What's the last piece of this puzzle? Believe it or not, it's time. We have to make sure every single device on the network agrees on the exact same time. It sounds kind of minor, but I promise you, on a network, timing is everything.
The granddaddy of time protocols is NTP, the Network Time Protocol. This is the standard for keeping clocks on servers, routers, and pretty much everything else in sync. It's absolutely critical for things like accurate security logs and authentication systems. But what if you need even more accuracy? Like way more. That's where PTP, the Precision Time Protocol, comes in. This is for high-stakes environments like industrial manufacturing or high-frequency financial trading. For the exam, the key difference is precision. PTP is accurate down to the microsecond level, which is just insane. Whew, okay, we have covered a ton of information. So let's switch gears. It's time for a rapid-fire review of the absolute must-know, non-negotiable concepts from this section. If you're studying for the Network Plus exam, you'll want to lock these in. First up, DHCP terms. You have to know them. Scope, lease, reservations, relay, and exclusions. Don't just memorize the words. Make sure you can explain what each one actually does. It's guaranteed to come up. Number 2, SLAAC versus DHCP. Be crystal clear on this. Remember the key difference. SLAAC is stateless and serverless. It just uses router ads. DHCP is stateful and needs a dedicated server to manage everything. Third, DNS records. You'll almost certainly see scenario questions where you have to match a record type to its job. Know your A and AAA for IP addresses, MX for mail, CNAME for aliases, and PTR for those reverse lookups. No excuses. Next, DNS query responses. You have to understand the difference between an authoritative response and a non-authoritative one. If the server is the owner of the record, it's authoritative. If it's just repeating something it learned from its cache, it's non-authoritative. Simple as that. And last but not least, time protocols. Just remember this one thing, precision. PTP is way, way more precise than NTP. Think microseconds. If you see a question about industrial systems or finance, your brain should immediately go to PTP. That wraps up section 3.4. Make sure to check out the next section as we continue exploring the topics in the CompTIA Network Plus exam by ASM Educational Center.